webinar. Thank you for joining us today. We are happy that you decided to spend the next hour with us. Whether you work in network operations, cybersecurity, today's session is designed to be highly practical. The title of today's webinar is "An Attack is in Progress. Can you see it? Can your team see it? Network monitoring that works in practice." As we often say at Psychop, the network always tells a story, and today our guide through this story will be Maciej Wilamowski, who will be leading us through this session. Maciej is our Chief Innovation Officer at Psychop and combines deep expertise in cybersecurity, machine learning, and large-scale data analytics. Alongside his role at Psychop, he's as well professor at the University of Warsaw. So he has this academic background as well. I'm Magda Bonsala. I'm marketing manager. If you will have any issues with the webinar, let me know at the chat. Ask question. There is a space for you to interact with us. We will be answering the questions on the chat. So I guess, Maciej, the virtual stage is yours right now, and I will be in the background.
All right, great. So welcome, everyone. Again, my name is Maciej Wilamowski. I'm a Chief Innovation Officer, and I will have the pleasure to give this webinar to you. So the whole idea for the subject of this webinar came from one of the discussions I had with Paweł, our security expert. And the gist of the discussion was as follows: like, a lot of communication, especially marketing communication regarding security products, focuses so much on stopping the intruders. And if you were to believe the marketing communication of most of the vendors that offer you security products, you would be prone to believe that you are immune to attacks. Everything's going to be okay. But at the same time, from time to time, quite frequently, we read the headlines about breaches. And those breaches affect major players: Pentagon, DoD, F5, Red Hat, and so on and so on. So on one hand, we want to focus on prevention, so keeping the attackers at bay. But on the other hand, we know that we cannot believe in our security, and there should be more focus on post-intrusion detection. So basically, what hopefully I will show you today by reviewing several case studies is that most of us are not focusing enough on post-intrusion detection, and we should be doing more, and it is possible to do more. So let's start with 3 statistics. So once again, we had this discussion with Paweł, and we said, okay, let's research this subject. And those 3 numbers are the ones that stood out the most from this research. So statistic number 1, the median time to detect an attack is 11 days. Let's think about it. What does it mean? It means that not only you're not stopping all the attacks, but in half of the cases, the time between the intrusion and your detection is 11 days or more. 11 days or more. That is a lot. What's more, the statistics from multiple reports suggest that only 46% of attacks are detected internally. So what does it mean that they are detected externally? It means that someone else gave you the information that you were compromised. It can be law enforcement, it can be independent researchers, and so on and so on. And again, less than half of attacks. So not only we are not detecting everything, we know that there is going to be intrusion sooner or later. This is what statistics suggests. But there is a high probability that we won't even be able to detect the attack ourselves. And the third number can be viewed as shocking, is that the record time that we know of between intrusion and action, let's say, was 12 months. So the attacker gained access to the system and waited full year to start acting, and the detection was even later on. So this is what brings us to this question. Yeah, so there is a chance that your network is already compromised. So the question is, how long has it been going on? And are you able, or are you even trying to notice it actively? So let's get back to the numbers and let's add some more perspective to it. Yeah. So again, median time to detect an attack, 11 days. So it's 10 days when it's being detected internally, but much longer when we are being notified by someone externally. More than half of attacks are not even detected internally. And now let's add two more very important statistics that show you why we have those problems. So statistic number one is like right now, 80% of attacks are somehow hidden in encrypted traffic. So we know that encryption on one hand is a necessity to keep the privacy, but we also know that it makes life of security officers much, much harder. And the other, let's say, inconvenient truth is that in most organizations, the internal east-west traffic is not actively monitored from the security perspective. And this is one of the main reasons why we are detecting so late. Yeah, so if the intrusion happens, we are detecting the intrusion so late because we are not actively looking at the behavior inside the network. So we are so focused at the perimeter that we very often forget to look inside. So this is the overview of those reasons. Yeah. So first, we know, obviously, that our log retention must be limited. We cannot keep all the logs indefinitely. Yeah. This is a structural problem. There is nothing we can do about it. We can optimize it a little bit more or a little bit less, but we cannot have infinite log retention. East-west traffic is very rarely monitored. Yeah? So when we use CMs for security, very often the east-west traffic is not logged by default because the volume would be too high. Again, encryption very often is our blind spot. And most tools are designed for perimeter-based security. The attackers also know that if they will be active at night or during the weekends, the alerts will be handled more slowly in most organizations. One more thing is that quite a lot of our infrastructure moved to cloud. And fact of the matter is, again, that cloud and container environments are often monitoring gaps. So once everything is inside the cloud or inside the containers, we are not monitoring what's happening inside. And last but not least, our focus on perimeter defense makes it so that if somebody has the keys, we are not looking into what this person is doing. So if somebody has the right credentials, either OAuth or something else, it almost never triggers an investigation. And this gap can be closed, but only if we know it exists and we start looking. So to keep everything quite lively, again, we will be going case by case. And we created a slight meme for every case. But we really think humor is the best way to keep you thinking and to let you easily memorize the lessons we should have from that. So very often when we think about security, we think about, password cracking or anything like this. But again, recent case studies show that brute forcing a password is so easy to detect and so easy to stop that almost nobody is doing that anymore. So what they are focusing on is stealing working keys. Yeah. So we might be feeling okay with ourselves if we are actively looking for brute force and we know that we can stop it. But if we are not monitoring the activity of the users that are using valid keys, there is a huge chance that someone is using stolen keys and we are not looking at it as a possible intrusion, and this will make us detect it very, very late. So again, the background of this case study. So most major organizations are using some kind of software service. When we use it, we must integrate with that one way or another. And the most popular way is using OAuth 2.0 protocol. And basically what it does, we hand out some tokens. We say, these are the keys. If you have it, you can access the system with the roles and rules according to how we set the token. So again, who uses that? Basically every major player. HubSpot, Salesforce, whatever you want to look into, quite a lot of things. We are mentioning the CRM-related platforms for one very good reason. But again, in large organization, it is possible that you have over 100 different SaaS integrations. We know that average cost of data breach is huge. And there are hundreds of organizations that are affected by a problem like this. So again, the reason why we are mentioning these types of integration is that in 2025, there was a famous drift out attack from Salesloft. So what happens? So the problem was that, again, everything started by getting the keys. And once you have it and you start looking into everything you can, and you get the keys to a system like CRM, it turns out that you can gather the information that you first had the access to and escalate your privileges. Why? Because in systems like this, even though we should not, we are keeping quite a lot of credentials. Yeah, so very often there is for example, via the CRM integrations, we can have access to all the correspondence, all the email correspondence with our customers. And in this correspondence, sooner or later, there are going to be credentials to different systems. So getting access to a platform like this means that it is very easy to get many, many more keys. So this is why it was really, really bad and really, really dangerous. But when you think about it, once someone gets the stolen key, again, the problem is that we are not monitoring what's happening. So when you think about it, when you compare the behavioral pattern of a regular user, so when I'm a regular user of this platform, I'm using my key, I'm gonna check my newest messages, I'm gonna go for the usual, newest things to do. And the behavior of an attacker is very, very different, because a person like this is going to try to look for everything they can. So what's going to be different in the behavior of the person who is an attacker versus a regular user? The activity is going to be much higher. The activity is probably going to be from totally different IP ranges. There is a very good chance that the data gathering will be automated. So the activity will be much higher, much longer, very often 24 hours, or at strange sessions like 2 a.m. or to 4 a.m. So when you look at that all together, when you think about it, you should ask, or at least we did ask ourselves this question, why it's not a standard practice to have those behavior analytics to have post-intrusion detection. Yeah, so we are coming back to the question from the start of this webinar, like why there is so much focus on the perimeter. And again, don't get me wrong, I'm not saying let's stop doing perimeter defense. I'm saying this is not enough. This is not enough because sooner or later, for some reason, even if the reason is as trivial as someone stealing a valid keys, someone will get through into your organization. And in those cases, very often, the behavioral pattern of the intruder will be very, very different than the one of your regular users. So if you have some way to have this behavioral analytics, you will be able to make a detection of the intrusion much sooner. And if you detect the intrusion much sooner, the cost of this data breach will be much smaller. So again, what would help in this particular case? In this particular case, again, behavioral API baseline, connection time analysis, visibility boundary, because malicious activity happens outside of your network. And in cases like this, very often, if you were very good historical NetFlow, this will be the way to do this behavioral API. Yeah. So again, I told you what is possible to do in terms of general sentences. Yeah. So we say API baselining and traffic baselining, but then you should start thinking, okay, so what kind of data I need to have to be able to do this post-intrusion detection? And one is some sort of log analysis, but as we know, the CM systems are already kind of strained. And the other is NetFlow, because when you keep the NetFlow data, it gives you the ability to have quite high retention of all the metadata of the traffic in your network. And this gives the ability to have this behavioral baselining. So again, another very popular case. Somebody is already in your network and they start exfiltrating the data. And again, modern attackers are patient. Modern attackers want to avoid detection. So they will do data exfiltration slowly and patiently. And again, this meme might be, funny, but you might think, well, it will never happen in real life. It's exaggeration. Or is it? Yeah. So we know probably if we are working in any security related field, we know what Red Hat is. We know what GitLab is. We know that basically Red Hat is a heart of world's critical infrastructure. Yes, it's not the only player, but when it comes to major companies, a lot of them are using Red Hat. We know that Red Hat is using GitHub internally. Yeah. So because they are using that internally, they have, sub-repositories, sub-branches, and so on per customer. So we know that Red Hat had or has 28,000 repositories. And again, what happened? Someone gained access to that. 28,000 internal repositories were compromised. 570 gigabytes of data was stolen. Yeah. So somebody gained access and slowly and patiently exfiltrated the data. So you might think 570 gigabytes is quite a lot of data. How on earth it went unnoticed? Well, it went unnoticed because it was slow. So most of the perimeter defense against exfiltration is looking for any large transfers that are going to the outside. Because if the transfers are small, they are hidden among the regular traffic. And again, do we have the tools to have this baselining of data egress over longer periods of times? Yeah? So do I have right now in my network something that will not look only at previous minute if there's a spike of data egress somewhere, but over periods like hours or days? What kind of data I need to have to even be able to do things like this? So this is not the only case, but why it was so serious? Well, it was so serious because, again, when we have our repositories that are Git-based, very often, one way or another, we will be keeping credentials in there. This is basically a fact. Yeah? This is basically a fact that developers, DevOps, engineers, and so on are keeping credentials, or the credentials are leaking in there. So if somebody gets access to your Git repositories, there is a very, very high chance that they will obtain keys to different systems or to the systems of your customers. So this is a critical data breach. Yeah. So again, what would have helped? This was a volumetric exfiltration. So analysis of total bytes sent to external IPs within time window, but this time window must be broader, hours and days. Many sessions to one destinations. So what kind of data do I need? On one hand, you basically need to have good retention of your NetFlow data, because otherwise you have no chance of this behavioral baselining or longer time frame analysis. And it is very good to have packet recorder to be able to do forensic analysis after the breach was discovered and do some, legal evidence to know what was stolen, where did it go. So yeah, now let's look at the case number 3. So we know how popular EDRs are right now for security. Give like solutions like CrowdStrike or whatever, put our firewall / antivirus on your edges and you'll be safe. Yeah. But nobody is installing software like this on your critical infrastructures like routers. So again, Juno OS. Juno OS is the operating system of routers. And again, maybe not familiar to everyone, but Uniper Networks produces network devices used by both telecoms, banks, governments, huge institutions, and so on. So major networks, major players are using the hardware provided by Uniper Networks, and this hardware is governed by OS. So it runs on routers, on switches, but it is important because this is basically the software that decides where every packet in your network goes, from emails to financial transactions. But what is also important is that very often devices like this can be also used with activity related to encryption. Yeah? So basically, whoever have the controls of your router, they control the traffic in your network. Yeah? So a backdoor on a network device can enable the attacker to eavesdrop on communication, manipulate traffic, block access, and create many, many different things. Yeah? Who uses that? Again, companies from Fortune 500, telecoms, banks, governments, basically all the big players. And again, what happened? And I would like to point you to the dates of the cases. We didn't have to go back many, many years to show you case studies that are very, very serious. All those things can be considered recent. If we were to show you the cases from previous 10 years, the list would be much, much longer. So I'm telling you this because these are not rare exceptions. Intrusions like this are happening every day to a lot of companies. And still, there is not enough attention to post-intrusion detection. So what happened? There was a blind spot, and it was possible to have a backdoor on routers, enabling visibility into your network traffic. It probably was espionage campaign by China-linked threat group. There was a 0-day in Juno OS, and basically their access was, I don't want to say unlimited, but very, very large. So what was visible in the network if somebody was accessing your router via the 0-day in Juno OS? So some kind of SNMP, SSH connection to the IP addresses outside the normal management profile, GRE tunnels from the routers to external servers, management traffic outside the normal behavioral baseline. And again, basically only NetFlow will give you this information. Maybe you can have some information in logs in CM, but in this case, probably only NetFlow will give you this clear signal that something is going on. Yeah? So again, let's review what would help. Yeah? So again, we have a backdoor on the network device. So first of all, we need some kind of management baseline for the network devices. Yeah? We want to say what kind of activity to the management traffic is okay, is regular uses. They should be communicating from our internal network. They should be communicating in regular traffic hours. Actually, because of the criticality of this infrastructure, we probably should be able to narrow down the list to the users who should have access. Any type of GRE tunneling, anonymous encapsulation protocols detection will be helpful. Yeah? So again, if we are connecting to the management interface on our routers, this should be done in a very regular, predictable way. So detecting that is possible if we are analyzing all our flow-based traffic. Yeah? So if we are analyzing our traffic with flow-based metadata, we can see anomalies like this. And if we add any geographic correlation of destination IPs, this should be very, very easy to spot a problem like this. So case study number 4. And again, it might seem funny when we look at it from this perspective, that we are saying we are a major player, we are saying we have a great security, and we say, well, I'm keeping my logs for 12 months. This is a huge retention. I can block every script kiddie, every brute force. And even if there is a successful attack, because I have a great log retention, I'm going to get to the bottom of the problem. But if the attacker is a nation state, they can be patient. They can wait. So we know that they can steal your master keys and wait even for 12 months. So you will not be able to tell who stole the keys. So again, F5. F5, very, very known company. They have a solution called BigIP. And basically, this is a gatekeeper for almost every important application. So F5 does load balancers and decryptors. So why it is extremely important is because they have very often TLS termination. So there is a very, very high probability that if somebody gets full access to your F5 device, they will be able to view your traffic as unencrypted. So again, application delivery controller manages HTTP, HTTPS traffic, balances load, very often terminates SSL, and protects against attack. And again, it sits in front of your government data, banking data, hospital data. One of the largest, most serious vendor when it comes to solution like this. So if you have the source code to the BigIP, it basically reveals how to get into the infrastructure that is load balancing and decrypting your traffic. And you can find 0 days, or sometimes it's even hard to call them 0 days because very often the companies that are developing the software knows about vulnerabilities, but are not able to patch them very, very quickly. So there is a chance that they are 0 days only from the customer perspective. But basically, if you get the source code, you have the blueprint, and it's very easy to give yourself a master key. And again, I'm showing you only the cases related to major players to give you the ability to realize that these are not, things that happen by mistakes because someone is a small organization and is not taking the security seriously. Juniper, F5, Red Hat, all of those are very enterprise-oriented and security-oriented. Yeah? And it happened to them. So if it happened to them, it can happen to you. And to show you the scale, some statistics show that basically 50% of enterprise web traffic is passing through F5 devices. So again, what happened? There was initial access through some kind of F5 server accidentally exposed to the public internet. So this is the way how they got into. So after they got into and security access for the future, they wanted to cover their tracks. So they went dormant and stopped activity for more than a year to outlast the log retention. And after that, they exfiltrated the source code of BigIP, all the internal vulnerability reports. Basically, they gave themselves a master key. Yeah? So what was probably visible in the network C2 beacon, quiet checks every n minutes. Retention beyond 12 months was basically the only chance to reconstruct the initial access, but even that was very, very hard. There was nighttime exfiltration split into small sessions. And again, the attacker planned around the retention window. So what would have helped? So the most important thing would be to detect C2 beaconing. And again, as we know, if someone is a state actor and is very deliberate in their behavior and very patient, it might be really, really hard to detect C2 beaconing, especially if they are not using any of the known C2 IP addresses. So some kind of behavioral cyclic analysis. So is there like this cyclic activity from time to time for one particular IP address that looks like C2 beaconing? Very long NetFlow retention, pickup recorder for critical segments. So yeah, this is the hard one. Let's be honest. This is the hard one. But again, if we were focusing on post-intrusion detection and not so much on the perimeter, there is a much higher chance that the attacker would be detected. So I think that we need to start asking the questions about security to the security vendor slightly differently. We should ask about retention, and we should start asking about post-intrusion detection. Yeah. So again, how the landscape of this problem look like? So we know that we have the external world, the internet. Then we have some kind of firewalls or next generation firewalls. Then we have core switches, and then there's the inside. Yeah, application server databases. Here we have this east-west movement. The good news is that even this east-west movement goes through our routers or switches, and if they are reporting NetFlow, then we have the ability to see into this activity and also make post-intrusion detection. So because a lot of traffic, even internal traffic right now, is encrypted, we need to be focusing more on behavioral analytics and not only on signature-based, packet-based analysis detection. We really, really need to be looking into the east-west visibility, because very often this type of activity is the way to detect the behavior. Yeah. So again, when I had this discussion with Pavel, this discussion that started the whole idea for this webinar, think about it. What happens after the attacker gains the initial access? What are usually their next steps? In most cases, it's not like they immediately gains full access to the exact place where we keep the data so they can do the data exfiltration. It's in modern attacks, it's almost never like this, that day one, initial access, day two, massive exfiltration. It almost never happens like this. So what happens? I have initial access, then I have usually network mapping. So after the attacker gets the initial access, he starts mapping the network that he got the access to. What is the structure? What are the databases? How we are controlling the Active Directory, and so on and so on. Can I escalate the privileges I already got? And when you think about mapping the network and the attempts for privilege escalation, this should show you that if somebody gains access like this, this should be a very, very different behavior than of anyone who is already in your network as a regular user. So one of the examples we made for one of our customers when it comes to data that you can get from NetFlow and the analysis of the sessions to your critical infrastructure. Think about it. If you have Active Directory server, almost everyone will tell you that, well, I have so much activity into the Active Directory because a lot of my edges, my users, and so on, are constantly verifying their access. It is impossible to see anything of value in there. But a regular access to Active Directory server has very specific characteristics of session length, number of bytes exchanged, and so on, how many sessions there are. And if someone is trying to get, for some reason, either is trying to get or already got privileged access to your Active Directory server, the sessions start looking very, very differently. So basically, you can flag anything that is not a typical session to your Active Directory server, and you can look at the user that has this atypical session. Because basically, if you have a critical Active Directory server, only few people, and probably also not every day, should be accessing it as a management role, admin role, and not as a regular user that only authenticates himself. So it is possible to detect the intrusion at the early stages where the attacker is trying to map your network and escalate his privileges, but you need to be monitoring the inside of your network from this perspective, and you need to have east-west visibility. Yeah? If I have too many alerts without this historical context, there are going to be too many false positives that will paralyze every SOC. If I have only real-time monitoring without an archive, it means basically that I have zero retention, zero forensic abilities. If I don't have historical data, I have nothing to compare. I have no baseline. So if I have no baseline, I cannot tell you about the anomalies. So to sum it up, we showed you today 4 case studies, 4 recent case studies that all were related to big players and had huge impact of their customers. And we know that breaches are going to happen. They are happening and they are going to happen. But what we can start doing differently is put more effort into post-breach detection. Yeah? So the monitoring that will give you this chance is east-west visibility, long-term data retention, behavioral analysis, not only signatures, retrospective packet access, and automated response. So hopefully this was interesting to you. It gave you some fresh perspective into security. We think that this is a really, I would say, the next frontier and the next best thing we can start doing. We know that there was so much focus on the perimeter that I would say that the solutions that are giving you the perimeter defense, well, we probably can call them mature, and there is, very little chance that there is a huge progress to be made there. We know that even though we were focusing on our perimeter defense for years, people are still getting through. And we know that the attackers are not doing high damage immediately after the access. So we have time to react, but we need to start looking at post initial access detection. So attackers plan long term. Attackers are very happy and usually free to move after they gain the access. And what does your monitoring do about this? This is the question I want to leave you with. Yeah. Okay. So this is it. The reason why we were thinking about this perspective is that our company has a product that is very, very good at NetFlow collection with large retention and its analysis from security perspective, visibility perspective, and performance perspective. If any one of you is interested in our offering, please contact us. We really have very, very cool solutions that look at the security slightly different and can offer you post-breach detection exactly from the behavioral perspective. We have right now many integrations with different systems, either Discord, Jira, Zabbix, Suricata, Slack, basically whatever you need. And because our system can get the information from both packet analysis and NetFlow analysis and can have very large data retention, this is why we live in the middle between network traffic analysis and network performance monitoring and network detection and response. And we give you this shared context with behavioral baselining based on historical data. And this is basically why our proposition is kind of unique from this perspective. Okay, guys, I'm monitoring the chat. Let me know if you have any questions regarding this presentation or our company or our offering. And if you do, either put it on chat or contact us later on. This is it from me. Thank you again. And I hope I will see some of you in person next time.
Thank you, Maciej. Very insightful, super practical webinar, even for non-super technical person like I am. We will send to all participants the video recording, obviously, and to some of you ask about the presentation. Probably that will be confirmed with Maciej, but we will be able to send it as well. Thank you for joining us today, and we invite you to follow us on LinkedIn, follow the news about PsyCop. We will be coming back soon in September with many new things, new product related news. So I hope to see you there online or on site. Have a great afternoon. Bye.
Yep. Thank you. Have a good day.